In this practice, we're gonna analyze a mechanical test. In this specific case, it would be the tensile test. And for that, we're gonna use a universal machine. The universal machine would work with a load, that in this case is the force applied to the material, and with an extensometer, that is this device that would measure the length and the strain. This would be so we can measure the resistance of the materials that we're going to use, that in this case would be steel and aluminum.
In this machine, we are going to put our test tube. Here, we are going to measure how much strain you put on the test tube. And with the extensometer, you measure the elongation of the piece. You don't take off the extensometer until the graphic in the screen says so. After a little while, these two parts will separate, and then the piece is going to break. The steel pieces take little time to break because they are harder, while the aluminum pieces take longer to break. That is because the aluminum is softer and it gets longer before it breaks.
The first thing we do before test the piece, we fill those pages. The first one, the material was aluminum 6061 and the steel 8620. Then we measure the length with a vernier, like from here to here, from the two pieces. Then we measure the area with the diameter. We measure the diameter with the vernier too, like putting in here. Then we measure like 0.5 millimeters to here and to here.
After testing the material, we got this data. The velocity of the advance of the head edge is 5 millimeters per minute for both the steel and the aluminum. The charge of deformation and the last charge, we got them by using the graphic. And the final length and the transversal area, we got them by using the vernier.
After using the universal machine, I'm applying floor to these little pieces, one out of steel and one out of aluminum. We have two graphs. This one is for the steel one, and this one is the one for aluminum. Then we need to know how to read it. So we have here a red line, a blue line, and a green line, which all means something different. In this case, red line, it means like elastic point, the last elastic point. If we stretch a material so hard, there's gonna be a point where it won't return to its original form. The elastic point at this steel is really close, which means that there is not a lot of flexibility in it. Then we have the blue line, which means permanent deformation. The more strength we add to these little pieces of steel, the more deformation it will have. But when we pass the red line in between the blue line, this damage will be permanent on the material. Then we have the green line, that is the ultimate tensile strength. In the ultimate tensile strength, that's the last strength that we could apply to this until it breaks, and then at least we have the breaking point, which is the point when these little two pieces of steel break. Cut.
The first thing that we calculate was the deformation. This one is like final length minus initial length over the initial length. The second one was the initial area, is what is P times radius squared. The third one was elasticity modulus, that was stress, that is force over initial area over strain. The fourth one was yield strength, that was the blue line, and was force over initial area.
The sixth one was tensile strength, the green line, that was also force over initial area. Then percent of elongation, that was final length minus initial length over initial length times 100. Then percentage of area reduction, that was initial area minus final area over initial area times 100. As we can see, the results in the chart that we got and the results that are published are quite different. Here we can see that the elasticity module is around 21 million psi, while the yield strength and the tensile strength are around 35,000. While on the published results, the elasticity module is around 9 million and the yield strength and the tensile strength are around 21,000. That means that we got higher results. That was the aluminum chart. Here in the steel chart we can see that we have around 1 million psi in elasticity module, 96,000 and 100,000 in yield strength and tensile strength. In the published results, there is around 30 million in elasticity module and around 10,000 in yield strength and tensile strength. That means that the elasticity module is the only result that we got lower.
After comparing the properties of the aluminum and the steel, we could realize that the resistance varied. This is due to the arrangement of the atoms and also the bonds that are between them. In this case, the aluminum took longer to break and the elongation was longer. And the steel was really quick. When we realized this, we got to see the importance of the tensile test and the mechanical properties, because we realized if we want to build a plane, we wouldn't use steel, we would use aluminum. And if we were going to build a house, we would use steel and not aluminum. So as an engineer and as designers, this is really important for our life because everybody else's life depends on it. So the testing of the materials is really important.